Hello everyone, welcome to the channel Understanding Concepts of Physics. We are doing topic on waves, and in case you have not subscribed yet, subscribe my channel, subscribe the channel in case you have not done so yet, and keep following the videos from the playlist in order to understand physics in a better manner. So today we are going to take a topic which is a theoretical topic discussing only the properties of a stationary wave. So we are going to do only a 7 points of properties of stationary waves. Hopefully you will enjoy and understand things pretty well. Now, in order to do the properties of stationary wave, the first point is basically the definition of stationary waves, which we have been doing that in previous videos. So when you get two progressive wave traveling in a medium along the same path but in opposite direction. Same path means they should be traveling in the same path, but one going right side and one going to the left side. So when you have such kind of wave and when they superimpose with each other, then the resultant wave obtained in the form of loops is called as a stationary wave. So I hope you got it. When two progressive wave traveling in a medium along a same path but in opposite direction superimpose with each other, then the resultant wave obtained in the form of loops is called as a stationary wave. If you want to have much more detail about this, then I would suggest you to go back in the previous videos to get the I have explained this in a very detailed manner. Then the second point you can add is the definition for nodes. So you see the properties of stationary wave ka topic is so simple that you just have to remember the definitions of stationary wave, and the second point is the definition for nodes. So what are nodes? Basically the points which vibrate with minimum or zero amplitude are called as nodes. They are also called as displacement nodes, and they are also called as pressure antinodes. This is again I have discussed in previous videos. Then we come to antinodes. So the third point will become antinodes. So the points of the medium which vibrate with maximum amplitude are called as antinodes, displacement antinodes, or pressure antinodes. So this is my third point. So first point is the definition for stationary wave. Second point is the definition for nodes. And third point is the definition for antinodes. And now the fourth point comes wherein you just have to mention the distance between two nodes is lambda by 2, distance between two antinodes is lambda by 2, and the distance between a node and an antinode is lambda by 4. So node to node lambda by 2, antinode to antinode is lambda by 2 again, and a node to an antinode is lambda by 4. Okay, again this point is I have explained to you in much detail, showing you some diagrams. So these are the antinodes, and these are the nodes, points of the medium which vibrate with minimum amplitude, and we have discussed all this stuffs at some point. So you can just go in the playlist, just search for yourself and you will really find it. Then so if you get a question for 2 marks, then half marks will be provided for the definition for the definition of stationary wave, for nodes, for antinodes, and the distances. So that way you can score good marks. And then if the question is for 3 marks, then you need to add 2 more points. So what is that? So change in pressure at the nodes is maximum, and change in pressure at the antinodes is minimum. So if a stationary wave is produced, something like this, okay, so something like this, so this point is where the node is, and this is the point where the maximum change in pressure is occurring. This is the point where the maximum change in pressure is occurring. Same way here. So nodes are those points where the maximum change in pressure occurs, and antinodes are those points where the minimum change in pressure occurs. So that's what our fifth point is. So change in pressure at nodes is maximum, and change in pressure at antinodes is minimum. Then we come to the sixth point. Particles in the adjacent loops vibrate out of phase, and particles in the loop vibrate in phase. So what does it mean? It means that, okay, suppose if I have a stationary wave, something like this, which is seen on the screen. Now all these antinodes all the particles are actually going up. Let's say if all the particles are going up, then the neighboring loop all the particles are going down. So particles here and particles here, they are out of phase of each other because one is going up and the other is coming down. However, if you see particles, this particle and this particle, they all particles are going up. So inside a loop, all the particles go up, so they are in phase, and when in adjacent loops, all the particles are going in the opposite direction. So these two particles are out of phase. So this is one loop, this is another loop. So in adjacent loops, they are out of phase. In a single loop, they are in phase. So this becomes our sixth point. Okay. Then comes the seventh point, which is very simple. That's time period and frequency remain same for each particle. So irrespective of they are in the same loop or they are in the another loop or they are somewhere some third or fourth loop, the time period and frequency remain same. However, the speed of the particle at the antinode is maximum. Now see, when you have such kind of particle which is vibrating like this, we are here. So if the particle here is going up and the particle here is going down and here the particle is going up, so all the particles will go up together and all the particles will come together down. So if this takes, let's say, half a second or 1 second to come down, this will also take 1 second to come up. So the time period remains same. So the amount of time required for one complete vibration will remain same. Okay, so time period is same, and because time period and frequency are reciprocal of each other, if time period is same, the frequency would also remain same. Now that is for time period and frequency, but the speed of the particle may be different. So speed, so because this is going to have travel a larger distance, like going from the extreme positive to the extreme negative, this particle has to be very fast, and this particle is going to vibrate slowly. This particle is not at all vibrating itself, so its velocity is 0, but the velocity of this particle is slightly more, and the velocity, the speed of the particle is maximum for this. Okay, so this is what the seventh point is. However, the speed of the particle at antinode is maximum. So speed is maximum. Remember that I'm not saying about velocity, because velocity comes out to be a vector quantity and that will come out to be 0. Okay, because nothing in stationary wave is moving. So speed of the particle is maximum at the antinode because the displacement is maximum and because the time is same. So basically it's like speed is equal to distance upon time. Because at the antinode the distance is maximum, the speed would be maximum because t is constant for each particle. Okay, so these are the 7 points of properties of stationary waves, and subscribe the channel in case you have not done so. You can just share it to other friends and families who can get benefit out of this. I'll be posting all the related topics of physics as and when time keeps on going. Okay, thank you so much for watching. Have a nice day. Bye.